All right, we're looking at rational exponents. And so as we're looking at these, we're going to adjust how we think about these radicals and indexes from thinking about them just as like doing a square root or the third root or fourth root to thinking about them as fractional exponents. So whenever I have x to the third power, for instance, if I did that, if I did the third root of that, then we know that should just equal to x because I have three x's. That makes a group of three, and so they cancel each other out. You could also think about that, and the way we're going to start writing that, as it shows us here, is if I had x to the third power, then the third root of that, then we do p, which is 3, and q, which is also 3, over each other. And so you could say, well, instead of writing it like that, you could write it as x to the 3 over 3 power. Then that just simplifies down to that 1 for x to the first power. So that'll work the same way if we have the exponent inside the house or if we've got it outside the house here. So looking at it here, the square root of 8, writing it just as a rational or fractional exponent, we'd write that just as 8 to the 1/2 power. Then 5 to the 8th power, the cubed root of that, just rewrite that as 5 to the 8 over 3 power. And then the fourth root of 3x cubed, I just write that as 3x. Then the exponent is 3 and over 4. Okay, so still doing the same thing. It still works the same way, but what this does is by changing it to fractions, this actually allows us to do some things mathematically a lot easier than if we have it in the rational or in the radical. So now let's work on going the opposite way. If I have 4 to the 1/5 power, that would be the same thing as saying we got a 4 inside the house, and that's the fifth root of that. So I would need 4 times itself 5 times, or 4 to the 5th power, in order to cancel that out. Same thing here. We got 16 to the 5th power. And then the 3 is going to be my index on the outside. And in a similar way here, we got an index of 4, and the 5xy squared is going to be just to the 3rd power. So we could put it there. We could also put the whole thing in parentheses and put the 3 on the outside. We could even distribute that 3 into the 5. So I'd do 5 cubed, x cubed, and then y would be to the 6th. Just depends on what we're doing with it as to what would work best. Okay, so moving on, we're going to evaluate this expression without using a calculator. So an easy way to think about this is that exponent is how many times, and they label it as p. So I'm going to think repeat. So I'm going to repeat a 4 3 times, and then the 2 is going to tell me how many groups, or how many in each group. So I'm going to repeat the 4 3 times, and I'm going to do groups of 2. So groups of 2, because that would be my index to the 2nd power, or index of 2. So 4 times 4 times 4. When I do that, that gets me, well, I've already got a group of 4s right there. And this 4 right here is going to be able to split up into 2 2s. And so when I move those both outside of the square root, it becomes 1 4 and 1 2. And they combine together, and I get an 8. So it's saying, really just saying, I could also do 4 times 4 is 16 times 4 is 32, and split that up into, if I take 42 or 32, I'd split that up into fours or twos, and I would have ended up with the same thing. And now they're bringing back in a negative. So remember, a negative puts that 9 underneath the fraction bar. So I'll put the 9 underneath, but it's also the 1/2 power. So I'm really doing the square root of 9 underneath there. And if we remember, 9 splits up into 3 and 3, I'm just doing the square root. So that would end up equaling just 1/3. When I've got 8 and 2/3 here, remember I'm going to repeat it twice. So I have 8 and 8. And I'm doing the cubed root, so an index of 3. Now, if you remember for 8s, or shortening of it, you could say it's 4 times 8, but 4 is just going to split up into 2 times 2. So I always think of my 8s as being 2 times 2 times 2. And since that's the cubed root, that helps us out quite a bit because I've got a group there and a group there. Again, you could do 8 squared, so 8 times 8, and put a 64 in there. You'll just end up with the same result because you'd have a 64, and then you'd immediately go split that 64 up into 8 times 8. Since I've got 2 groups of 2s, I'll do 2 times 2, which is 4. And next, I have 32 to the negative 3/5 power. So that means 32, and I'll break this apart into some steps. 32 to the positive 3/5 power. Then, if I look at 32, I know that 4 and 8 is 32, and so I can already think of this as, well, if I split this up into the 5th root, then it's already going to work out a little bit easier because 32 splits up into 8 times 4. And 8 is 2, 2, 2, and 4 is 2 times 2. So I actually have 2 to the 5th power there. So what that does is cancel it out. And so it'd be 2 to the 5th power divided by 5. And so since that's to the 3rd power, I end up with 1 over 2 to the 3rd power, which would give me 1 over 8. Other way to think about that would be if I cube it first, or I repeat 32 3 times. So this is an alternate way of thinking about it. I have 1 over the 5th root of 32 times 32 times 32. And when I split that up, there'd be an 8, 8, 8, 4, 4, 4. 4 and 2, 4 and 2, 4 and 2. And so I already have 1, 2, 3, 4, 5. 5 fours that would come out. And that's 4, we just have to split up into 2s. And I have 1, 2, 3, 4, 5. So I'd have 5 fours. So it's a 4 that comes out and a 2 that comes out, which still gets me to 1 over 8. Because remember, this was in the underneath the fraction bar. So either way, whichever way you think about splitting it up, it's going to get you to 1/8. If this way is a little bit too confusing, you've got some more factoring that has to be done there, but definitely still going to work for you. So on the back, it wants us to use laws of exponents. And this is where it starts to help you out a lot. Because when I'm doing 5 to the 3/4 power times 5 to the 1/4 power, I know that laws of exponents says I can just do my exponents added together. And if I do 3/4 plus 1/4, that equals 4/4 or 1 whole. So that would just be 5 as my answer. Same thing on number 12. When I distribute, I make it much easier because I do a to the 1/2 power to the 6 power. It would give me a to the 6 over 2 power, and b to the 6 times 2, so b to the 12 over 3 power. Then what I've got are two fractions that'll simplify, and 6 divided by 2 would give me 3. So a to the 3rd, and 12 over 3 would be 4, so b to the 4th. This keeps working for us as we go along. So do the cubed root of 27. So 27, we'll just go ahead and write it like that. And c to the 6 over 3, and d to the negative 3 over 3. So that's just distributing that 1/3. Okay? And then I get 27 splits up into 9 and 3, or just 3 3s. So that's going to come outside as part of my answer. C to the 6 over 3, I do 6 divided by 3, which is 2. So c squared. And then d to the negative 3 over 3, which would just be d to the negative first. Or that d, in other words, would just move down to the bottom. And that would be our answer. For number 14, I'll distribute this 2/3 out, just like normal. So I'd have 8 squared to the 3rd root, so 8 and 8. And then a to the 12th would be a to the 24 over 3. Then the cubed root of 27 times 27. And b to the 18 over 3. Okay, so if I do the cubed root of 8 is going to be 2. That'd be 2 2s, which gives me 4, because I split up 8 both times into 2, 2, and 2. You do that twice. 27, I'd split up into 3, 3, and 3. We do that twice. And so be 2 2s, so 4. And 3 times 3, so 9. Then let's simplify the fractions here. A to the 24 over 3 would give me a to the 8th. And b to the 18 over 3 would give me b to the 6th. Okay, so this keeps going kind of in the same way. Since we're multiplying here, remember we'll multiply everything together that is the same. So 5 and 2 gives me 10. I have x to the negative 2/3 plus x to the 1/3 give me x to the negative 1/3. And then y to the 2/3 to y to the negative 1/3 would give me y 1/3 power. And so then it's just adjusting that around a little bit. We'd have 10 times the cubed root of y over cubed root of x. Same thing on number 16. We're just adding exponents. I have negative 3, negative 4, negative 3, negative 2. So just combining all those together gives me x to the negative 2/5 So would simplify to be 1 over the fifth root of x squared. And last but not least, with our fraction, I would do negative 3 over 6 gives me a negative 1 over 2. And then I do 2 sevenths minus 8 sevenths, or say 8 minus 2, and that stays on the bottom. So a to the 6 over 7. And then you could rewrite that as a to the 6th power and taking the cubed root of that. And on all of these, you can leave that as a fraction. These as well. Actually, might call it a little more simplified if you just leave that as a fraction. So call that 10 y to the 1/3 over x to the 1/3. It gives you a little bit more simplified, and the same thing with this one here.